In this video, we'll be looking at how to prove the quadratic formula. Now, if you haven't yet done it, please take this time out to subscribe to the channel. So we want to look at how to prove the quadratic formula. Now I'm going to lay out some groundwork. I know that many of you guys are already familiar with this formula right here. You use it to solve many quadratic equations. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. But we are going to look at where this thing came from, alright? And there are several ways how you could prove this thing. But the approach I'll be taking is to use the concept of perfect squares, alright? So let's say we had something x squared plus, let's say 6x. Now I can make this thing a perfect square by simply adding half the coefficient of the x term, so half of this thing right here, so half of 6 and then squared, all right? And this thing would give me a perfect square. So this thing is the same thing as x squared plus 6x plus 9, and we know that this thing is the same thing as x plus 3 all squared. So if you expand x plus 3 all squared, you will obtain x squared plus 6x plus 9, right? So let's look more at what we want to get at. So I'm going to integrate this concept. So I did that so you can follow me when I do that. So let's start off with a quadratic equation. Let's say we have ax squared plus bx plus c is equal to 0, all right? Now the first thing that we want to do, we want to divide this entire equation by a. That would leave us with x squared plus b over a times x plus c over a is equal to 0. Alright. The next thing that we want to do, we want to move this c over a on the other side. So we'll end up with x squared plus b over a x is equal to minus c over a. Now again, I want to make this thing a perfect square, all right? So I want to make this thing a perfect square. So what I'm going to do, I'm going to add the required constant to do so. So again, we can obtain that constant by simply, so we're going to add half the coefficient of the x term, which is b over a, so half of this, and then we are going to square it, all right? And remember, we didn't always have this thing in the equation, so if we add this thing to one side, then we must do the same thing to the other side. So I'm going to put it at the front right here, over a all squared, and we still have the minus c over a, all right? Ensure that we have all of that in there. So this is where we're at. So what I'm going to do now, I'm going to expand the brackets. So this thing, we have x squared plus b over a times x plus this thing works out to gives us b over 2a all squared, and this thing, same thing on this side, b over 2a all squared minus c over a. All right. Now let's expand this thing a little further. So we have x squared plus b over a x. If we square both when we square in a fraction, we square both the numerator and denominator. So this thing works out to give us b squared over 4a squared. Same thing here, b squared over 4a squared minus c over a. All right. Now, what we want to do next is to write this as a perfect square. Now, what I want you to examine is the relationship between this thing right here. So notice when you had the quadratic equation, So after we add the required constant, then what you will have here is x plus half the coefficient of the x term all squared. Alright, so we are going to do the same thing here. So we'll have, so all of this thing, we are going to rewrite it as x plus half the coefficient of the x term. So half of b over a, that's b over 2a. And we have to square this thing, alright? And this thing is equal to b. What I'm going to do, I'm going to make this thing one denominator, alright? So I'm going to make this thing one fraction, alright? So this thing will work out to give us b squared minus 4ac over 4a squared. Now we can now square root both sides. If we do that, we're left with x plus b over 2a on this side. And if we square root the numerator on this side, we'll end up with b squared minus 4ac. The square root the denominator will get 2a plus or minus 2a. Alright, so we can now move this b over 2a on the other side, and we'll end up with x plus b, well, b over 2a minus b over 2a from both sides. We'll end up with minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Alright, so this thing cancels that, and we're left with x is equal to, and remember this thing, we have common denominator, so we can make this thing one fraction. So we have minus b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and there you go. That's the quadratic formula for you. So that's how you go about proving the quadratic formula. Remember to like, share, and if you haven't yet done it, please subscribe to the channel.